Hello, Physics Nation. My name is Nate Larmond, and I'd like to do a sample calculation for the trundle wheel experiment. So in the last video, I asked you to make one of these things. We're just going to chop up some cardboard, make two circles, chop up some cardboard, make two rectangles. We're going to attach the rectangles to the wheel with an axle, that is a pencil, and then you put two clips on either side, and you've got yourself a trundle wheel. All right, so hopefully you've built this thing. But how do you use it? That's the point of this video. Oh, you're going to use it to measure your house and your property and all that. But let's do a little sample calculation. It's a pretty simple measurement. You need the diameter of your wheel. So for my wheel, let me just disassemble this thing, take off the clips. So for my wheel, it's about, let me see here, it's about 14 inches, 13 and a half inches. For this little wheel, it's a penny, and it's 1.9 centimeters. So the way you do this is you mark a little position on your wheel, that's your reference point, and then as you roll the wheel from one position to the next, you count the number of rotations. So here, let's put the tape at top dead center. Right there, that's a quarter of a rotation. From there to there is 1/4 of a rotation. And I took you through the penny rotation, so this is roughly half a rotation, half of the penny's circumference. Let me back up just a little bit. Pi is probably the most famous ratio in mathematics. It's the circle's circumference, that is its perimeter divided by its diameter. So if you know the circle's diameter, you just multiply by pi to get its circumference. And for the penny, the diameter is 1.9 centimeters. Multiplied by pi, the circumference is roughly 6 centimeters. So you just take the number of rotations the wheel goes through as you move from one position to the next, and you multiply the number of rotations by the circumference of the wheel. And that's really all there is to it. That's how far your trundle wheel has moved. So like I said, this is roughly half a rotation of my penny. Half of the circumference is 3 centimeters. So this line right here is 3 centimeters long. Here, I've rotated through almost a full rotation. So from here to here, the penny, the trundle wheel, has moved 6 centimeters. This is almost 2 complete rotations. What would that be? 1 3/4 of 6 is like 10 and a half. And this isn't the greatest diagram. 2 1/3 rotation should put the dot right about here, more like 10 o'clock position. Anyway, 2 1/3 multiplied by 6 is 14 centimeters. So the entire length of this line is 14 centimeters. That's my little penny sample calculation. Rotations multiplied by circumference. That's how far your trundle wheel has moved. So like I said, for my personal trundle wheel, the diameter is roughly 14 centimeters. If you multiply by pi, you get a circumference of 44 inches. We can double check that real quick. So check out the Make Your Own Metric Tape Measure video. It's amazing. Let's double check that measurement real quick. So let's actually measure this circumference directly. And right there is where it started to overlap, and boom, little over 110 centimeters, or 44 inches, divided by 39.37 is 1.12 meters. So here we go. In the frame of the webcam, I can get about 1/4 of one rotation. There's top dead center, the big piece of tape. Now it's at 3 o'clock. That's 1/4 of a rotation. 1/4 of 44, the circumference is 11 inches. So when it goes from here to here, it's moved roughly 11 inches. Thanks for watching. See you in the next video.